In order to write good proofs, there's certain pieces of information that we can infer to be true. Like if we know that an angle is a right angle, then we know that its measure is 90 degrees. Now if you think about it, if we measure an angle and we get 90 degrees, then we know that that angle is a right angle. So we can start here with knowing that an angle is right and conclude that its measure is 90 degrees, or we can measure an angle, find that it's 90 degrees, and conclude that it's a right angle. So this inference goes both ways. We can start here and end here, or start here and end here. And the reason we know this is true is by the definition of a right angle. This is the definition of a right angle. Notice that when we have a definition, we can infer both ways. If we know that we have perpendicular lines, we can conclude that they form a right angle. And the reason we know this is true is by the definition of perpendicular lines. That's what it means to be perpendicular. Two lines are perpendicular if they form a right angle. Now since this is a definition, we can infer the other way. If two lines intersect to form a right angle, we can conclude that those lines are perpendicular. So to prove lines are perpendicular, we need to prove that they form a right angle. Or if we know that two lines are perpendicular, we can conclude that they do form a right angle. If two angles form a linear pair, we can conclude that they are supplementary. Now, the reason we know that a linear pair of angles is supplementary is not by the definition of a linear pair. The definition of a linear pair is two adjacent angles whose non-common sides form an opposite ray. That doesn't say anything about being supplementary. It's the linear pair postulate that lets us conclude that those angles are supplementary. The linear pair postulate says if two angles form a linear pair, then they are supplementary. Notice that this is not a definition, because I can't work both ways through this inference. If two angles are supplementary, I cannot conclude that they form a linear pair. They might, but they don't have to. Now what can I infer about supplementary angles? Well, if two angles are supplementary, then they sum to 180 degrees. And if we look, if two angles sum to 180 degrees, we can go backwards through this inference. So we can start here and conclude this, or we can start here and conclude this, because this is a definition. The definition of supplementary angles states exactly this. If two angles are supplementary, then their measures sum to 180 degrees. If two angles sum to 180 degrees, then they are supplementary. We can follow that same logic for complementary angles. If two angles are complementary, then their measures sum to 90 degrees. And if two angles sum to 90 degrees, then they are complementary. That is the definition of complementary angles. And since this is a definition, the inference can go both ways. We can start here and conclude this, or we can start here and conclude this. And the last inference that we're going to need for 3.6 deals with vertical angles. If two angles are vertical, we can conclude that they are congruent. Now if you think about it, if I start here, two angles are congruent. Can I conclude that they're vertical? Well, not necessarily. Just because two angles are congruent does not mean that they're vertical. But if two angles are vertical, I can conclude that they're congruent. So this is not the definition of vertical angles. The definition of vertical angles are two angles whose sides form two pair of opposite rays. They form two opposite rays. This is actually the vertical angles theorem. And the vertical angles theorem is the piece that allows me to conclude that vertical angles are congruent.